In this presentation, we will discuss one problem related to types of relations. So let's get started. Here is the problem. Determine whether relation R on the set of all real numbers is reflexive, symmetric, antisymmetric and or transitive where x, y belong to R if and only if x plus y is 0, x minus y is a rational number, xy equal to 0, x equal to 1 or y equal to 1. Relation R which consists of all ordered pairs of this form x, y where x plus y equal to 0. Actually this is given in the question that x, y belong to R if and only if x plus y equal to 0. This means we are considering this relation, that is set of all ordered pairs of form x, y where x plus y equal to 0. Now we have to determine whether this relation R on the set of all real numbers is reflexive, symmetric, antisymmetric and or transitive. Let's first discuss the reflexive property and let's see whether this relation is reflexive or not. For all a belong to real numbers, a must belong to R. This is according to the reflexive property, right? Now let me tell you this relation is not reflexive because x plus y is 0 when x is 0 and y is 0, right? This is true when x is 0 and y is 0, but for x equal to 1 and y equal to 1, this is not true. For x equal to 2 and y equal to 2, again this is not true. Therefore, it is clear that this relation is not reflexive. Now let's discuss whether this relation is symmetric or not. According to symmetry property, for all b belong to real numbers, a, b belong to R implies b, a belong to R, right? Let's consider some arbitrary a and arbitrary b, okay? Then a plus b is 0 and b plus a is also 0, right? So it is clear that this relation is symmetric. We know that if a plus b is 0, then b plus a must also be 0. I am considering some arbitrary a and arbitrary b. Actually, a, b belong to R means a plus b must be 0, right? If a plus b is 0, then b plus a must also be 0, which means b, a must belong to R. Therefore, relation R is symmetric, right? Now let's discuss whether this relation is antisymmetric or not. For this, we will consider this property, that is for all a, for all b belong to real numbers, a, b belong to R and b, a belong to R implies a equal to b. Let me tell you this relation is not antisymmetric and let's see this with the help of an example. Let's consider x as 1 and y as minus 1. First we will consider 1 plus minus 1. We know that 1 plus minus 1 is 0 and minus 1 plus 1 is also 0, but 1 is not equal to minus 1, right? Here in this case, instead of a we have 1 and instead of b we have minus 1. A, b belong to R, b, a also belong to R. That means 1 plus minus 1 is 0 and minus 1 plus 1 is also 0. But a is not equal to b, that is 1 and minus 1 are not equal. Therefore, this relation is not antisymmetric. Now let's see whether this relation is transitive or not. For all a, for all b, for all c, a, b belong to R and b, c belong to R implies a, c belong to R. Let me tell you this relation is not transitive. Let's see this with the help of an example. 1 plus minus 1 is 0. Minus 1 plus 1 is 0. I am considering a as 1, b as minus 1 and c as 1. Okay. 1 plus minus 1 is 0 and minus 1 plus 1 is also 0. But 1 plus 1 is not equal to 0. Right? That is a, c does not belong to R. Therefore, this relation is not transitive. So it is clear that this relation, which consists of the ordered pairs of the form x, y, where x plus y is 0, is not reflexive, not antisymmetric, not transitive, but this relation is symmetric. Now let's discuss is x minus y is a rational number. That is, we must consider the relation of this form. That is, we have an ordered pair of this form x, y, where x minus y is a rational number. Here you can see that this relation is reflexive because a minus a for some arbitrary a is always 0, right? And 0 is a rational number. Therefore, this relation is reflexive. Now let me tell you that this relation is symmetric because if a minus b for some arbitrary a and arbitrary b is a rational number, then b minus a, which is actually minus a minus b, is also a rational number because negative of a rational number is also a rational number. Right? Therefore, this relation is symmetric. Now let's see whether this relation is antisymmetric or not. Let me tell you this relation is not antisymmetric and let's see this with the help of an example. Let's take x as 3 and y as 2. Then we know that 3 minus 2 and 2 minus 3 are both rational numbers, right? But 3 is not equal to 2. Isn't that so? We have replaced x by 3 and y by 2. 3 minus 2 is a rational number. 2 minus 3 is also a rational number, but 3 is not equal to 2, right? Therefore, this relation is not antisymmetric. Now let's see whether this relation is transitive or not. If a minus b is a rational number and b minus c is also a rational number, then a minus c, which is nothing but a minus b plus b minus c, is also a rational number, right? Because addition of two rational numbers will give me a rational number, right? Therefore, this relation is transitive. Let me tell you that this relation is reflexive, symmetric, transitive, but this relation is not antisymmetric, okay? A relation which consists of these ordered pairs x comma y, where xy is equal to 0. Now let me tell you this relation is not reflexive because a dot a, that is a multiplied by a, is a square, which is equal to 0 when a is 0, okay? But for the rest of the numbers, this is not true. We are talking about all real numbers, right? Therefore, this relation is not reflexive. Now let's see whether this relation is symmetric or not. For this, we shall take an arbitrary a and arbitrary b. We know that AB is 0. After replacing x by a and y by b, we got AB. AB is 0, right? And BA is also 0. Therefore, this relation is symmetric. There's no doubt about this. Now let's see whether this relation is antisymmetric or not. Let me tell you this relation is not antisymmetric because 1 into 0 is 0. 0 into 1 is 0, but 1 is not equal to 0, right? Therefore, this relation is not antisymmetric. And this relation is not transitive either because minus 1 into 0 is 0. 0 into 2 is 0, but minus 1 into 2 is not equal to 0. This is just an example, right? Here I have chosen these numbers minus 1, 0 and 2. Minus 1 into 0 is 0, 0 into 2 is 0, but minus 1 into 2 is not equal to 0. So, this relation is not transitive. Now let's discuss the relation R with the ordered pairs x comma y, where x is equal to 1 or y is equal to 1. It is clear that this relation is not reflexive because 0 comma 0 is not in R. When x is 0 and y is 0, then obviously x is neither 1 nor y is 1. Therefore, this relation is not reflexive. Now let's see whether this relation is symmetric or not. If a comma b belong to R, I am considering some arbitrary a and arbitrary b. Okay. If a comma b belong to R, then a is equal to 1 or b is equal to 1. It is clear, right? Either a is 1 or b is 1. This means b comma a must belong to R because either a is 1 or b is 1. We want at least one of them to be 1. Then only we can say that a particular ordered pair belong to R, right? Here we are saying that a comma b belong to R. This means that either a is 1 or b is 1. It might be possible that a is 2 and b is 1. Might be possible that a is 1 and b is 2, right? It could be any possibility. We should see this that when we are saying a comma b belong to R, then this means that either a is 1 or b is 1. So it is clear that b comma a must also belong to R, right? Therefore, this relation is symmetric. Now let's see whether this relation is antisymmetric or not. This relation is not antisymmetric. If a is 1 and b is 0, then a comma b belong to R, right? And b comma a also belong to R, but a is not equal to b. Isn't that so? Therefore, this relation is not antisymmetric. Can we say this relation is transitive? Now this is homework for you. You have to determine whether this relation is transitive or not. Okay? This will be your homework. Okay friends, this is it for now. Thank you for watching this presentation.